Hey guys, Pankaj here. Welcome back. So in today's video, I'm going to talk about the standard normal variate. We'll see what it is and where exactly we use it. And those who have not watched my previous video where I talked about what is Gaussian normal distribution, what are its properties, please go back and watch it, then come back to this video. Otherwise, it will not be, you will not be able to understand. Okay, so I'll share my desktop. Okay, so as usual, I'll be importing all the libraries to generate data and do some visualization. So I'll be taking this a equal to np dot random dot rand int. Okay, so I'll be generating, let's say, height of a male, which varies. Let's say it may be too less or too high. That's okay. But let's say 122, 180, and I want to generate data for 200%. Okay, and after generating data, let's do some KD plot. SNS dot KD plot of A. Okay, so if you see here, we have the peak somewhere around maybe close to 158 or 159, where your mean is there, right? So I can just get the mean by using A dot mean, and standard deviation, I can just use a STD somewhere 17, right? So what normal Gaussian normal distribution tells. So to have any data, right? So let me go back to whiteboard and I'll draw something so that you can easily understand. So as per Gaussian normal distribution, if any data which is following the curve where mu equal to 0, then mu plus minus 1 sigma will be somewhere here. This will be your 2, 1, and this will be 3. Similarly, here you will have -1, this will be -2, and -3, right? So if you know any data, let's say given data D where it is following normal Gaussian distribution where mu and this, or where mu equal to 0 and standard deviation equal to 1. Let me just write 1. Then we know that mu plus minus 1 sigma, 68% data falls in that category. That will be this 68% data, mu plus minus 1 sigma. If you have mu plus minus 2 sigma, then 95% data will fall into it. Okay, that will be this part. If we have mu plus minus 3 sigma, then 99.7% data will fall into this category. That will be somewhere from here to here. Let me use other color. So 99.7% data will be covered from between mu plus minus 3 sigma. Okay, this will be done only your data if it is following Gaussian normal distribution where mu equal to 0 and sigma equal to, that is standard deviation is 1. Okay, so in this data, whatever we just generated here, if you see mean is what, 150, and standard deviation is 17. So I cannot exactly tell how much percentage of data falls between mu plus minus 1 sigma, how much percentage of data falls between mu plus minus 2 sigma, and so on, mu plus 3 sigma plus minus 3 sigma, right? To do that, we have something called standard normal variate. Standard normal variate, which is represented as small z or maybe capital Z. Okay, so what exactly it tells, you take all the data, let's say xi, and subtract the mean from this and divide by standard deviation. This is going to transform your given data into Gaussian normal distribution, which will start following Gaussian normal distribution property. Okay, so you will have exactly mu equal to 0 and standard deviation equal to 1. Once you have this, then you can easily calculate all the data, which how much percentage of data falls under 68, 95%, and 99.7. Okay, so do this, we have to follow this particular formula, standard normal variate. So let's do that. So this is what we got before. So I'll just use here before standardization. Okay, Now I'll take after standardization. See what is happening. See the magic here. So how to do? We have to use z equal to x. This is nothing but your data a. Subtract this mean, right? A dot mean and divide whole thing by standard deviation. That is nothing but a dot std. Okay. Now you'll get the data z. This is the data we got. Now we are going to plot this and see the magic here. SNS dot kd plot z. Okay. See here what is happening. So after plotting, let me use some color here. Yeah. Take some color. Okay. You see here exactly your mean is somewhere exactly at 0. This mean is coming exactly at 0. This is your mean 0. And this is nothing but your sigma, that is your standard deviation. So now you have exactly bell curve, right? So what I can do between here to here, 68% data is falling. This is your 68% data. Okay. Now if you talk about mu plus minus 2 sigma, right? That is from here to here. So how much data will be coming under this category? So from overall data, I can say 95% data falls between, this will be plus minus 1 sigma, and this will be mu plus minus 2 sigma. And now if you are going to talk about further, here, let's say this was 3, right? So from here to here, all your data falls between 99.7% data is falling between mu plus minus 3 sigma. Okay, so this is the benefit of converting given data into standard normal variate. Okay, so that is the beauty of this particular theory. So you just take this formula, subtract each value of the given data from its mean and divide by standard deviation. Then your whole data will be converted, or it will be called as standard normal variate, because whole data is transformed into standardization, which is going to follow the Gaussian normal distribution. Okay, so now after conversion, you can easily say, right, okay, the data which is between mu plus minus 1 sigma is nothing but 68% data is there. Okay, similarly, mu plus minus 3 sigma, I have 99.7% falls between this from here to here. That is the beauty of it. Okay, so I hope you understood. This is what I wanted to show about standard normal variate. And just practice with different data, generate some random variable and do the KD plot. You will see mu and their standard deviation. Then divide, subtract each value by mean and divide by standard deviation. And then you do the KD plot. Then you will see your mean is exactly falling at 0. And by the way, I can just prove it by showing this also. So z dot mean, you see here, it is 2.5 and e to the power minus 16. It is very close to the 0. Okay, and if you talk about the standard deviation, it is exactly 1. This is what we were trying to achieve by doing standard normal variate. Okay, and same thing is shown under this KD plot. Okay guys, so that's all about this video. I'll be uploading this notebook in the Jovian and GitHub also. You can just download and do the practice by changing the dataset. Okay, thank you so much. Bye-bye.